So we'll be presenting on making simulation a sustainable business function, and we'll explain how we undertook that in this project and how we served our clients, Transnet. Right, so Sonwabo unfortunately had some technical challenges to join us, but he was representing the client today. Yeah, he's the head of infrastructure and capacity planning, also a senior manager at Transnet. I led the project as the project manager and was also involved in building models. Then Renier was our systems engineer, and Neil was our test subject and tested all the models for us and yeah, helped us get to the final product. Next slide. Great, so just at a high level, what we'll be going through. There's an introduction that we'll get to now, problem statement, the objectives, our approach, why we chose AnyLogic, the solution architecture, the model demo, why it's significant, and then some Q&A. So just a little bit about Transnet. They're a major freight logistics company within South Africa. In 2023, they moved just over 210 million tons of cargo, approximately 4.1 million containers, a lot of them out of the largest container terminal in the world, which is, in the Southern Hemisphere, which is Durban. And they handled over 8,000 vessels. This is across 8 ports in the country. Yeah, so they've got quite a serious operation going on, and their business extends into rail and pipelines, as well as terminal operations. Our client in this case was the Ports Authority, and no, all good. Thanks, Amir. And yeah, and how we undertook this challenge to address their needs. So they have issues around or challenges around capacity planning. And in the past, they've used very much a static approach to capacity planning. They used, let's say, spreadsheets, and they struggled to capture the dynamics of the port system, which is really integrated. So yeah, I'm going to hand over to Renier just to run through about how we tackle this problem. And then as we go on, Neil will join us later and speak about our models. So thanks, Renier. Over to you.
Thanks, Christian. Well, as you started describing, a lot of the challenges faced by the client was internally they did not have any simulation capability. So often when calculating capacity, it was done through static calculations, looking at the individual components, berth capacity, gate capacity, storage capacity. But now there was an integrated capacity assessment integrating across the marine, waterside, landside, and gate issues. When they did do simulation studies, which they have done for many years and do have quite of an experience within using simulation, the problem was that always that function was performed by external service providers. As a state-owned company, there's a lot of restrictions and red tape about how to engage with service providers and tender processes to go through, which makes getting new service providers challenging and maintaining a relationship with a specific service provider practically impossible. So what would happen is you would perform a specific study, have a simulation model built, answer the questions of that specific study, and next year, same port, slightly different question, can't get the same service provider, get a new service provider, and they're building a new model of the same port, different technology, and there was this repetitive redevelopment of models happening without really adding value. What also made it quite complex is the various different operations. You've got containers, you've got break bulk, you've got dry bulk, you've got liquid bulk, and all of these things, there are some specific port software looking at container terminals and optimizing that. But within the port system, there's all the various different components that one has to look in together. So with that in mind, the guys from TNPA and Sonwabo's team approached the market asking for simulation software providers to provide them with the simulation software that will enable them to do the capacity planning. So in terms of our approach then to tackle this problem, or let me first just cover what their objectives was with this simulation software. They wanted a tool to provide a futuristic view of their port plans and to analyze future demand, enable their teams to predict operational impacts across the different port precincts, simulate the port processes to identify bottlenecks and improve efficiencies, and then calculate and validate capacity for all the commercial ports. As Christian has showed, there's 8 different ports in the country, and being able to do the same approach, same calculation across all of those ports. And then obviously support TNPA in their oversight role. TNPA is the port's authority of all these ports. So they're the landowner of the port, and the terminal operators then get an operating license from TNPA to handle a specific cargo at a specific terminal utilizing the resources in the port. But for that, they need to maintain certain operating standards. So with that, TNPA has got an oversight responsibility to make sure everyone is operating within those requirements. So our approach from the start was, this is more than just a simulation model. This is not just a single project study to answer what's the capacity of a port, or even what's the current capacity of all 8 ports. It was about a full system solution to, yes, answer the question about the capacity of the ports today, but also enabling TNPA as an organization to continually answer that question as demand changes, as vessel dynamics and vessel sizes change, as demand for different commodities change. And yes, things are expanding, you've got growth, but you've got other commodities that might be declining. And how do you reallocate resources and manage those processes? And then the big element around this also then equipping their organizational structures, the people, with the necessary skills to develop it. So one of the key elements in our approach was to develop this standardized approach. And with that, we'll talk about a port library and our data structure just a bit later. And I mentioned the organizational changes needed. Why did we choose AnyLogic? Because firstly, it can run simulation models. That's just an obvious one. But one of the key features that AnyLogic does provide is that ability to develop your own library, so that we can standardize the way certain things in the models are done across all the ports, and not only for the models that we develop now, but any model that the client then develops in the future. So we can standardize on those processes. The fact that it's built on Java helps that you can export to the Java executable and easily run multiple iterations in parallel in the background. And then there's an extensive talent pool. There's very few, I don't think there's any other simulation product that has quite the user base and the user base out of the university environment. So you're constantly getting this pool of young, bright people that's got experience in the tool. So when they start coming into the organization, they already have that basis of understanding, well, how do I model within AnyLogic? So now it becomes a process of, well, the domain knowledge and understanding the port processes and getting that. And then obviously it's ideal for a scalable solution, firstly from the licensing aspect, the team license server being able to share licenses, but then also being able to check that in and check that out across the organization and add to those licenses. So as your team grows, you can just buy an additional seat on the team license and you can grow your organization. So it's great in terms of license flexibility and then scalability in the organization. And what we heard about more today is also the Git repository management and how that is also evolving and making it easier to share models and co-develop on models within a bigger team. So the solution architecture that we came up with was looking at the various different components within the solution. As I said previously, this is not just a simulation model or a specific simulation study. So we looked at various components. We've got the business users that's really just interested in answer my question. I want to know what the capacity is, or I want to know what impact will this have if we stop doing bulk operations in this port and we change that to another container terminal. Those type of questions. We've got the capacity modeling and analysis team that's responsible for answering these questions. And then we've got the internal systems, the source data that we use to drive these simulation models. So the way that we've structured it is we've got the model development, whether it being an internal team developing the models and storing the source models within an SVN server, or whether it's external service provider that can access the source code through appropriate firewall and security measures so that you enable the organization again to scale up. So we've got a couple of big projects, we want a couple of answers, but we don't have the team in place. Easily onboard a service provider to help assist in building an extra model or modifying a model, but can then incorporate that again into the ecosystem. Then on the data side, as I said, there's a lot of input data, and I'll talk a little bit more about it just now, but the way that the data is structured and received from the different source elements to prepare that going into your simulation model to develop your study, but then also the results from the study. A simulation model never gives you a single point answer. You don't just press play and the simulation runs. At the end of the day, the magic number is X or 42. It's always a whole bunch of output KPIs that one has to analyze and build the storyline. Why is this happening? Why are we seeing the queuing time for the trucks increasing in front of the coal loading station? And being able to plot that. So pulling back out the output data from the simulation model becomes equally important as the input data, and then being to analyze that. So for that, we've got a database server and integration server working with the data. And then we've got this application server. Now, the application server is really just a web front end to build our metadata and the structure and managing the whole process. So it's kind of like the AnyLogic Cloud, but specific to the client's problem. So it's a lot more than just inputs for a simulation study. It's the whole process that we've encapsulated into a web application, but can then also kick off the simulation run execution, as well as the database interaction. So don't worry that you can't read any of those elements. That's not the point, but that was the data structure that we came out with from. We've got various ports, and in each port there's a port number of precincts, there's key walls, there's berths on them, and to that, certain commodities are handled across different berths. So a berth can handle more than one commodity, and a commodity can be handled at different berths, and you've got different terminal operators. So that whole mix coming into how this is structured and the rules one can set up. But at the end of the day, determining the capacity in a port is about saying, how much am I trying to get through this port system? And then measuring, well, how is my port system performing when I am doing that. Now, what that means is we can simply say, oh, I want to export 60 million tons of iron ore. But there's now so much more that comes into play with that, because that 60 million tons is not a pipeline that just opens and it speeds out at a constant rate. That needs to go into specific vessels. Vessels have a specific size, so they are batched into vessel packets. On the coming into the port side, that material is coming in by train. Those trains are specific sizes and coming in certain packets. So being able to set up all that configuration and how that relates to a specific demand set when you are trying to do 60 or trying to do 61, 62, how we increase that, that's what this data structure is then all about, and what we then manage through the web interface. So the structure is we've got the SQL database in which all of the data is sitting, and then we've got the port simulation portal through which we can then set up and define all these things. So as I'm saying, I've got a port demand set, and that demand set is all the commodities that can be handled at that port, how much of it is being imported, how much is being exported, what sizes vessels are being used, what's the parcel sizes going into the vessels. So some vessels carry more than one type of commodity. Some vessels, like containers, you've got containers coming off, being discharged, containers going on, being loaded. You've got transshipments where the container is just going off of this vessel to be picked up from a next vessel, and you need to be able to configure all of those things. So that's what we set up through the demand set. We can have our metadata about the cargo, those commodities, how they set up, the vessels, their sizes, and then obviously some related settings on that. All of that, as I said, is stored now in a central SQL database. And then when you start the AnyLogic model, it draws that data from the database to build up the internal data set in the simulation model. So each time you run the simulation model, it's with updated, fresh data from the database. What this also enables you to do is one person can work on the data. So a data specialist is responsible for looking at the data. Another person is the AnyLogic modeler. So he's in his AnyLogic on his laptop, developing the model, testing the model, making sure everything works. But then when the model is published, you can have a simulation analyst who merely says, well, okay, I want to test these different scenarios, and then use the web interface to configure those scenarios, which the model will then execute by itself. For this to work and to be successful, a lot of these processes, for instance, how do I take that 60 million tons of iron ore and chop it up into vessels that are scheduled to arrive over a year at some distribution, inter-arrival distribution in certain parcel sizes? That process of doing that, I would like to standardize that across all the different commodities, across all the different ports. So with that, we developed the port library, the TNPA port library for building these models. And that's where we enlisted our good friend, Dr. Ben Schumann. So it's starting to sound like the Dr. Schumann show today, but he's really did some excellent work with us on this. And to talk a bit further on the port library and how we've integrated into the models, I'm going to hand over to Neil.
Hi guys, thank you for the opportunity. Yeah, so I think René spoke about the main purpose of the port library, and that's to standardize the model development toolset. And it becomes very important when you have a team of developers with different modeling styles and experience levels, working on different models. I think the added benefits that we saw with the library is reduced model development time, and also a cleaner flow logic, which makes it easier for developers to navigate complex models and also, again, different models. And it also provided us with a seamless integration with the input data. So you never have to look at the data, you just drag in the blocks, and the data and the blocks already take the data into account. As Sir René mentioned, we developed this as a team. So Benjamin was in the lead, and then us as the model developers went with the toolset that he developed, and we tested that. So we would give him some functionality that we wanted. He would develop it, and we test it, and then we gave our feedback, and then he went away and refined it. So just looking at the functionality that's currently in there, it can broadly be grouped into three main areas. So you have a marine side, a terminal or quayside portion, and then also you have the land side portion. On the marine side, again, as René mentioned, you have the vessel generation, which is driven from the demand and your expected vessels that you're likely to see. And you have blocks for moving those vessels on the network to the specific berths. And then you also have things like custom resources or custom marine resources like the tugs or the vessel pilots. And then you have the different marine resources like terminals, berths, and quay walls. And they also interconnected, also looking at the data, and that is ready to use for the vessels that you bring into the port. Then on the quay side, you have some logic blocks where you do your cargo handling with resources like cranes, forklifts, trailers, which is also provided in the library. And then on the land side, you have things like trucks, trains, and then your bulk material flow and fluid flow elements. So in there, again, this is broken down into your logic and layout elements. In fact, all three of the areas is broken down into those two distinctions. And then, yeah, it's you use these blocks to define the routes that the trains take, the trucks, and yeah, everything is provided in the library to move things around. And also on the output side, some standard KPI measurements has been added, and that also creates a cohesive modeling experience across all the different ports. I think a lot of effort and care has gone into the library development, and the result is a very mature product that the client can use to implement changes and do model development. And it just provides that consistent and cohesive modeling approach for the organization.
If I can maybe just add to that, one of the key principles that we implemented in the library and then also in the models is the separation between the layout and the logic. So what that enables us is to do the capacity planning we are talking about here is a 30-year time frame that we're looking at. So you can have your short-term plans, things going to happen in the next 10 years, a medium term for the next 30 years, and a long term beyond the 30-year window. So to be able to look at the same port at various statements we are able to build different layouts, which have then different storage areas, number of berths, depth of the draft available at the berth, and the associated infrastructure, and test that as different scenarios using the same model, just picking different layouts to run through. So I'm going to now just start a short video where Neil, please just add some context for us.
Sure. We're going to start off just looking at the different ports and just have a quick overview of the different ports. So the first one on the list, we're going to look at Richards Bay. So it's one of the two main dry bulk ports in South Africa, which handles about 54% of the total dry bulk demand. It also contains the Richards Bay Coal Terminal, and that's part of the one of the leading coal terminals in the world, with a design capacity of about 91 million tons. This is Durban Port, also located on the east coast of South Africa. It's the main container port. It handles about 60% of the container traffic. It also serves commodities like liquid bulk, break bulk, dry bulk, and automotive products. Next up is East London, a smaller port, about 600 kilometers south of Durban, and it focuses on the automotive industry and also the agricultural, dry bulk, and livestock products. Also recently, manganese is loaded from there. Next up is the port of Coega. It also handles container traffic and serves as a deepwater transshipment hub of South Africa. Also geared towards serving the Asian, the South American, and African trade routes. There you can see a bit of the KPI of live KPIs. Next up is Port Elizabeth. It handles container traffic, dry bulk, break bulk, and liquid bulk products. Cape Town, it's on the west coast of South Africa, and then handles passengers, containers, break bulk, liquid bulk. And this port is very unique with the weather challenges, also built into the model. This is the port of Saldanha. It's one of the deepest natural ports in Africa, ranking as the top iron ore export port on the continent, and also has prime oil and gas infrastructure. It also handles other commodities like liquid bulk, MPT, and LPG. Over to you, René.
Thanks, Neil. Just wrapping up why this was important. It's typically, as I said at the start, got single studies to answer a specific question. What this project was about is equipping the organization to continually answer these questions in the future using the simulation. So making it sustainable, not just a once-off element. We've already started using it and using the model within live workshops to assess, well, how is this working? What if we change the operation like this, enabling the customer to, sorry, to discover new ways of working. The organization has now accessibility to these, to everyone. And again, as I explained within the structure of the organization and what the simulation portal enables them, is that you don't need to be an AnyLogic expert. You don't need to be a simulation modeler to use the model to start answering questions and giving access to that information. So really surfacing the insights out of this and making it part of the organization. So with that, I think we've got 3 minutes left for some questions and answers. And if I look at the 2 that's open at the moment, Do you have to purchase a port library on top of the standard AnyLogic libraries? The port library is a bespoke custom development for our client. So at the moment, that is the client's IP and product, whether they one day want to package and commercialize that, that's up to them. But certainly learning from what was done in there and developing that further is definitely an option. I do think if you look at the available libraries within AnyLogic, you've got the rail, we've got the road, but we don't have a port one. So it's really begging for one to get included into the AnyLogic fold, into Nudge Nudge. But yeah, if that answers that question. How long did you take, you guys, to model all these ports? And that's where the magic happens, is that the project in total was a year. So in 12 months, everything that you see to date is more or less concluded. Yes, we still have a couple of meetings and crossing the T's to evolve, but effectively the project was over 12 months. A great deal of that was focused on the structure and the infrastructure building, and then Ben's development of the libraries. But once those libraries have developed, we had 3 people developing the simulation models for all 8 ports, and some of those models were developed in a matter of weeks. Some like Durban, which is quite complex, having various different traffic routes and rail structures, and that obviously take a bit longer, but the whole purpose of the model is to speed that up.